joining. On today's session, we will be looking at AI recommender system.
This conference will now be recorded.
So the agenda for today's session is introduction to the recommender system. So, where we need it and where and all we can use it, and how the recommender system evolved over the year. And we will look at the three type of recommender system which are predominantly used in the current industry. Um, Content-based recommender system, collaborative filtering, and matrix factorization method. We will look at in deep with a code demo for all the three approaches as part of today's session. So before we start, what is the basic problem that we are trying to solve? So typically the users use multiple sources of information at this point in time, and if they wanted to purchase something or they are looking for some specific details, how effectively the platforms or the solutions which are actually providing that whatever the users are expecting, that makes or breaks the actual company's profitability. It could be anything. It could be in terms of your e-commerce platform, it could be in terms of your video delivery platform. It could be anything that is interfacing with the users. If it is not providing what the users are expecting, and it is going to be a problem for that particular providers. Gone are the days or old websites which are static websites where things are very static, and it does not matter what type of users are going to access, how the users are interacting with. Now even many of the banking services, insurance services have come out with personalized recommendations. That is very important in terms of personalized recommendation based on individual users, what the user want, and based on which provide the details there. So that enabling this personalized recommendations based on user preferences, user details, is a very big problem. And at the early stage, many of the e-commerce providers and the actual video providers have tried to solve this, and they have to a certain extent solved it using machine learning. So we're going to look at how they did it, how they really solved the problem as part of a recommendation solution. This is very very common use case. I'm sure most of us have used some form of a video uh, provider service. So I'm sure you might have seen, if you have logged in. So I'm just taking this from a reference point of view. Somebody say Joshnu is logged in. Based on what they have previously watched, and top picks for Joshnu, meaning that specific to that user, a specific set of recommendations are being provided to the screen. And there is also one more section, and because you watched some specific movie, and it is going to tell that I'm going to provide a specific recommendations for you. Okay, so these two places, if you look at, effectively the machine learning plays an important role, or the recommendation system plays an important role in terms of what content has to come. And if you go and watch, log in with a different user ID, then the information that you are seeing here will completely differ for that particular person. The other details, for example the new releases or the trending now, could be the same for everyone. But in the case of the items that you see here, top picks for Joshnu, or because you watched some specific movie, these are some of the movies that you would be interested on. So this could be specific to the person who has accessed it, and that details are being provided. And this is one example where the recommender systems were used. The other example is in terms of e-commerce platforms. See, this is a very common one where e-commerce platforms like Amazon or Flipkart and you name it, Snapdeal and so many other, pretty much all of them have integrated the recommendation system, in the sense if you are purchasing a specific product, they will very clearly tell, people who have purchased this also purchased XYZ products. How do they identify that, based on this purchase, how all these other products were also related to this, where recommender systems plays an important role on identifying that. So in the future, if you look at pretty much on all the application that you see, it could be a retail based application, it could be anything related to a customer focused one. A personalization is going to be the future, and recommender system plays a very important role on bringing the personalization on your products and the solution that you are building, be it financial services, be it insurance, be it retail, healthcare. Everywhere we are going to see the recommender system play a major role in the coming days. And it has already started. Many of the large companies have implemented many of such solutions, and we're going to see that going to grow exponentially in the coming days. Right. So, what is the basic premise and how the recommender systems have evolved over the years? And effectively during 90s, predominantly you might have had the retail solutions and all were focused on static web content. So you had a product, you sell the product, that's it. But early 2000s, there are content based recommender systems were predominantly coming up, and toward 2000s you see a lot of collaborative filtering based recommender systems have come up. During 2006-7 area, the matrix factorization approach were pretty popular, and towards the next 10 years, the factorization machines were dominating the recommender system market. We're going to see uh, now in the recent developments, we're also predominantly focused on factorization machines and advancement on the deep learning and the neural networks. You basically apply the neural network for the factorization machines. So we will look at all these approaches, how we are going to do our recommender system, and using all the different approaches that we have explained here. Right. So before we get into the code, or before we get into understanding the different types of recommender system, let's understand what is the basic thing that is required for a recommender system to work properly. So the first thing is events. Events in terms of, it could be an implicit event. Implicit event could be you are browsing an Amazon website or you are browsing a Google, and what pages that you are viewing, what clicks that you are doing, what app interactions that you are performing, and that shows that you are interested on specific product, you are interested on specific item. And it could be commerce. For example, you are on Amazon and or Flipkart or whatever the solution that you are using, and you add some product to the cart that shows that you are interested on taking that one, purchasing that one, or whatever the products that you have already purchased, or any product that you have returned. These are some of the events that help recommend something for you. Or it could be some media that you are consuming, you are interested on specific item, you are looking those kind of an item on a TikTok or a YouTube or any other video audio platform. So you are browsing through these content, that means you are interested on such products. These are implicit event, in the sense without even you knowingly, you are actually providing these information to the companies which are collecting this data. The sense, if you are clicking on a specific product in Amazon, that means that Amazon already knows that XYZ person is interested on this particular product. So once you go back, you will see that because you have already clicked that product, you will see everywhere that particular product pops up. It could be any different website that you are browsing, that particular product related information pops up, advertisements pops up. How does it happen? Because all these large players record this information, record these events that are happening, and based on these events, basically they are providing this outcome to you. These are implicit events. Let's look at some explicit events. For example, you've already seen a movie, and you see that it is a very good movie, and you provide a rating for that movie and provide a comment, hey, this is a fantastic movie. So that shows that you have already watched it, and you are providing a comment, and you are doing it. Or it could be, let's say you bought a car, and you have to post, you are saying that they've delivered a fantastic experience for you. So you post that these guys have given a very good experience for me for the car. Now this is an explicit event. You are providing this in the public domain, that you are happy with the rating that is being provided, and you are providing some comments. This is a public explicit event. You are purposefully providing this detail to the users. And there could be specific intents predominantly on search queries. You go to a Google, so you want to purchase, say, um, um, an iron box, or say a water heater. So you go and search for a water heater, and suddenly Google understands that through this login, this particular person is actually doing a search query for a water heater. He is interested on it. Okay. Or there could be social event. The social medias were predominantly high, and everybody were focusing on. Could be YouTube, TikToks, and whatnot, Facebook, Meta, lot of them, Instagram, lot of them are there, and you constantly interact with it, and you provide content, you share the content and the details. These all details, go back to them as an input for an event. Okay, so this event is one set of information that will feed into the recommendation system. Okay, so the next set of information that will get feed in is the context detail. Context in terms of where are you currently accessing this information. So, what device that you are using. Are you using a web browser from a PC? Are you using a Mac? Are you using a mobile phone? What type of a mobile phone that you are using? All these informations are context information. And what time you are accessing this detail, what location, what type of event that you are interacting with. Have you come to that particular location from a different reference? What type of interaction that you are doing? Are you spending more time on a specific item? All these are context information that gives whether you are interested on it or not. Assuming that you wanted to buy a water heater, and you are spending, say, 15 minutes on searching for an item, that represents you are very much interested on the water meter. You are looking for a water meter to purchase. So that is a context information that you are sharing it to them. So effectively, given the user, event, and the context, predict the interest and recommend the top ranking outcome to the user is the basic purpose of your recommender system. Okay, and let us see in a short while how that is achieved. Okay, so before we get into there, let's take some example and see how that is that particular recommender system works from a basics. Let's take the case of we all are going to work in Netflix. So we all got a job in Netflix. So we need to build our recommendation system for Netflix. And we found that there are three important movies are available there in Netflix. And let's say the Expandable, Avatar, and the Spider-Man. And let's say three different users are interacting with these movies. Let's say Mali as a one person, and he has watched two movies out of the three, and he rated the movie Expandable with 4.0 rating, and the Avatar with 5.0 rating. Apart from this, as a system, these these movies already consist of the information about what is that movie is all about. That movie could be an action movie, movie could be a sci-fi or a fiction movie, and so on and so forth. These informations are by default available at Netflix. So the Netflix already has this detail, and when the user interacts with that particular movies, he also provides some more detail. So assuming he gives a rating for Expandable and Avatar, let's say he's a first user. So the second user, let's say a Shan, is also interacting with the movies, but he did not watch Expandable. He watched two other movies, Avatar and Spider-Man. Somehow he didn't like Avatar, so he gave 1.0 as a rating. But he liked very much the Spider-Man. He gave 5.0 as a rating. Let's say a third person comes, and this third person, effectively Gokul, he watched movie Avatar. Now again he is coming back to the, he logged into Netflix and he wants to see some movies. As a developer of Netflix, you need to provide the movie recommendation to him. I just wanted to have this as an interactive one. So I want to understand from you, how do you um, provide some kind of recommendation to the user? Any idea? What are all the different options that we have? So let me just give you the detail. So the first
Yeah,
approach, yeah, please go on, Rajesh.
we do have Expandables and Spider-Man, but I think as Malli likes both the movies like Expandables and Avatar, Gokul might
Right.
also like Expandables in this case.
Wonderful, wonderful. Okay, so this is, you are based on the user, because this user Malli has already liked the Avatar well, and he has given 5.0 rating. And Gokul is also seen that movie, and he also liked. You are grouping these two users together, and based on this grouping, that you are thinking that okay, these guys have already has seen this, it is better we provide Expandable to him because he'll also like this movie, right? So this is exactly what is a collaborative filtering. Okay, because you are collaborating the details, you are bringing a kind of a clustering that you are bringing in part of your solution, and you are collaborating the users based on their interest. And here you have collaborated Malli and Gokul into a single bucket, and you have removed Shan to a different bucket, and this is called the collaborative filtering approach. The other way to look at solving this problem is assuming that we already have, as a Netflix employee, already has what the actual movie is talking about. For example, what is the content of this movie? What the storyline of this particular movie? From the storyline of this movie, I know that what is the actual context, main context of this particular movie. And if I understand what is this particular Avatar does, because Google has already watched and he rated 5, if I can actually identify any other movie which matches the actual content of this movie, then he will like that as well, right? Here in this case, we are taking the content of the movie, and based on which we are providing the recommendation. Okay, so the basic two classification is either you take the content and provide the recommendation, or you do a collaboration approach, a user based collaboration approach to provide the actual rating. So that is the basic classification of uh, uh, the recommender systems. Okay, we'll come to the matrix factorization shortly. Okay, but we understood that there are two approaches there to actually solve our problem. That is the initial step. Let's first start with the content based filtering.
Uh, Hi,
Yeah,
Prasanna.
yeah, yeah.
Uh,
Go on.
yeah. So you just said there are two approaches. So one is the content-based approach, so where the
Correct,
content is nothing but the storyline or on a high
correct,
level, right?
correct, correct.
And the second one is collaborative approach. So what is collaborative? So that means multiple users give some rating, and based on
Right.
that particular rating, so you'll come up with the
Exactly. So now,
result.
for example, from the diagram that you're seeing, so
Mm-hmm.
we found that Gokul is currently rated, has seen Avatar movie. Okay, he's given 5.0 rating. Okay, and as a Netflix employee, we need to recommend a movie for Gokul when he logs in. Okay, what is a movie that we can recommend? So
Okay.
from the user, that three movie and three user that you see, what is the movie that we can recommend? I'm just asking a question. So
So
if
other
Gokul,
than these three
yeah,
movies, other than these three movies.
no, we will take only these three. Netflix has only these three movies, and only these three users are going to access it. Okay,
Okay.
so two users have already accessed and provided the rating. Okay, and Gokul is currently already watched the Avatar movie, and we have to recommend him the next movie. Okay, so how do we recommend him the next movie?
Mm,
Here, if you look at the rating provided by Gokul and Malli, okay, so now Malli also watched Avatar, and Gokul also watched Avatar, and Shan also watched Avatar, right?
right. Right.
Right now, Malli has also liked it very much. He has given 5.0. Gokul also liked it very much. He has given 5.0. But Shan did not like it, so he has given only 1.0 as a rating, right? So
Mhm.
should we collaborate Gokul with Malli or Shan? Who is he Gokul reflects more of? Is he reflects more of a Malli's rating or more of Shan's rating?
More of Malli's rating.
Exactly. So now, because both of them watched Avatar, both of them are giving 5.0 rating for Avatar. That means their interests were more or less same. Both Gokul and Malli's interests were more or less same. So we are going to do a collaboration with Malli and Gokul. We are going to ignore Shan here, okay? Because he has
Okay. Okay.
given 1.0 as a rating. So because
Yeah.
we are
Yeah.
going to collaborate Malli and Gokul, and in this case, Malli has already watched a movie called Expandable, which Gokul did not watch. So it is a
Okay.
better choice for us to provide Expandable as a recommended outcome for him,
Okay.
so that they can
Okay.
enjoy that one. So this is the collaborative filtering approach.
So
Okay.
rather than the
So I'm
Spider-Man,
just
like the expandables is the highest. Okay.
exactly, exactly. So I'm just simplifying to a very, very basic level, but there are a lot more has to be done. I'm just simplifying the concept. Once you understand the concept, we can go into the technical part of it,
Just
right?
to just one more
Yeah,
question here. So I mean,
yeah,
technically, so when we are collaborate with the collaborative process, this is the place like we get the concept or something similarities.
right. Yeah.
Okay.
So similarities as such, yes, true. Um, Effectively, the first approach is the content-based one, right? So now, first
Mhm.
approach is where we're going to do. Yes, we're going to do the similarity, but the how you find the similarity will vary for both the approaches. Okay,
Okay. Okay.
I will explain to you shortly about one by one. We will
Sure.
start with the content-based approach, and then we will go to the collaborative approach. Now, we're all clear that what is a content-based approach, right? So let me just reiterate what the content-based approach, so that we can go into the next level. Okay, so the first item we will see is the content-based approach. So in the content-based approach, we are not going to bother about the user at all. Okay, whoever is coming, we are not going to bother about it. Okay, so if anybody has watched, say for example, Avatar as a movie, and to recommend another movie, we're going to take the content of the avatar. Now, the content of the avatar consists of multiple items. Say there is a description of this movie, and there is a genre of the movie, what genre that particular movie is actually, and based on this information, we're going to do the recommendation. So we're going to find in the database of all the other movies, find movies which are similar to the content of the movie. We are not going to bother about the users, what they have watched, what they did not watch and all. So it is based on the content we are going to provide the ratings or recommendations. Okay. So now, what is the basic problem that we face in the content based approach? So here the first problem is, uh, let's say this avatar as a movie, there is a textual information that is there. So because textual information is there, as a human being, I can read this detail. Okay, it is talking about some corporate mission, that is an important detail, and they wanted to find whether the particular person is loyal or not. Um, so that is what the whole context of this particular movie. And there are some important words which talks about native inhabitant, and there is a corporate mission, there is a loyalty that is being looked at from an avatar movie. So now, if I wanted to identify a similar movie to avatar, then I need to identify a similar keywords which are available on any other movies. So I need to first decipher what is this particular movie is about. I need to understand that context of this particular movie, and based on which I need to go and identify what is a similar movie which is having a similar storyline as such. So once I have the similar storyline, I can order them based on the ranking of that particular movies and provide that details to the users. So that is an approach. Now, because it is going to be English language, I need to understand the English language. Then we need to use something called natural language processing. So the natural language processing (NLP) consists of an approach to synthesize a textual data, a sentence data, to an embedding matrix. The embedding matrix, as such, is going to take the sentence, and it is because typically the machines that we are using does not understand English. All the machines and the machine learning operation that we are doing all understands only the numbers. Some way or other, I need to convert the textual data to a numerical way. What is an approach? The natural language processing has an approach called embedding. What is this embedding does is, it takes the important words which are available in that particular paragraph, and it assigns a number to it. Okay, it assigns a number to it. But if you look at this whole paragraph, there are a lot of junk words are there. The junk word is, for example, is, who, for, a, the. These are junk words. We don't bother about it. So there could be a highly important words are there. So once we make these words, for example, native inhabited Pandora, for example, it is an important word for us. And for example, a corporate mission is an important word for us. And loyalties, it is an important word for us. So what we need is, we need some top list of important words from this paragraph, so that we can look for a similar important word available across any other movie description. So this is what we're going to do. We look at taking a movie that we are going to process, and take that data which is in a textual format, and convert the data into a numerical format, that is called embedding. Once we convert it, we're going to look for the top 4 or 5 important text on that particular item. Okay, let us see how the whole approach is done. Once we identify this, we need to actually look for a similar kind of word that is available across all the other movie. Once we find a similar kind of movie, any matching movies, then we can consider that those are the recommended item, because we're going to take the content and based on which we're going to provide the outcome there. Okay, so to do this, what are all the different steps there? So the first step is we may have to get the data specific to the movies, and we need to process the descriptions of the movies. And once we process the description, we need to find a similar movies, and we need to rank them and group that particular similar movies. There could be similar movies, there could be hundreds of movies. We need to identify them and rank them there. And once we rank them, if we take the top 4 or 5, that 4 or 5 could be the potential recommendation for us, right? So that is what we're going to do. To do that, we're going to take a movie data set from a programmatic perspective. How do we achieve it? You take a movie data set, and the movie consists of a topic which is nothing but the description, and we're going to process them using NLP, a BERT transformer, and we're going to do an encoding of that particular the description. And once we encode the detail, encoding is nothing but assign a new value for each and every words which are there. But there could be lot of junk words there. So we might be focused on top 5 words which are our interest on that particular statement. So there is something called principal component analysis that is mainly used for dimensionality reduction. Dimensionality reduction, nothing but you can simply think of that as I had a paragraph with 100 words, but I may not be interested on all the 100 words. I'm interested only on the top 5. I take that using PCA. And once I take that value, I need to find the similar details available in the whole data set, the whole movie data set. How do I identify the similar data set? I identify using something called cosine similarity. So this is the 3 important step that we go through for identifying our outcome. Okay, I hope this is clear in terms of how you get the data for a content based recommender system, and process the data description using NLP. And once you are done with that, you create an encoding of that. And once the encoding is done, you apply a principal component analysis for reducing the dimensionality, because you have a lot of junk words there. We get only a specific top 5 words that we are interested on. And once we are done with that, using that 5 words, we're going to look at identifying similar movies from the whole database. That is done by using cosine similarity. So that is a technical part of it. Okay, so this is what we're going to achieve in the demo. So now let me directly take you to the demo, directly walk you through how we're going to achieve that. And I will just switch this. I will discard that. Let me go to this one, and let me take a content based recommender system. So the source code I have already shared it in the GitHub, and I would request you to look at that for reference. Okay, so let me just I hope you're all able to see the screen. So the first thing is I need to install the sentence transformer. This sentence transformer is the one which is going to help us transform the sentences that we are having in the movies to individual encoded outcome, that is assigning a number for each of them. So we have already successfully installed it. Okay, I'm going to import some of the important code content that I'm interested on. Okay, so the matplot library is mainly used for plotting uh, plotting graphs and charts. NumPy is used for your data storage. There is the sentence transformers. The sentence transformer is nothing but takes the data that you are having and convert the data to an encoded form. That is what is done by using sentence transformer. For providing for providing charts and graphs. Sorry. Okay. Uh, right. So hope you are able to see the screen, right?
Yes.
Yeah. Okay. Great. And I'm using sklearn's feature extraction uh,
Just
with,
yes.
yeah. So
So the
count
sentence
vectorizer. Yeah.
sentence transformer,
Yeah.
it's a just like a one library like NumPy
Yes. Yes. That,
and
that is what
pandas.
we installed here. Yeah. That is what we installed here. Pip
Okay,
install sentence transformer is a library that you have to install it before you start using it. That is what we installed here. Okay, and once you
okay.
install it, from there you can start using that here. Okay, yes, it is like a library, Python library.
So it's
Okay,
part of Python libraries. It's
yes,
right
yes,
one.
yes, Python library, yes, correct.
Okay,
Okay, so we're not going to use the k-means at this point in time. And the next is cosine similarity. We told that similar movies that we need to find, that we're going to get it using this cosine similarity. And the principal component analysis, that is what we're going to use for identifying the top 5 words that is required for our demo as such, for our processing as such. Okay, and you can basically ignore this part, and I'm just going to run this is just a plot that we're going to do. That is just definition of how the plot is going to done. You can ignore it. So I just imported things successfully. And the next is I have a data which is called IMDb. IMDb is one of the biggest rating provider for all the movies, and even the movies also been provided by IMDb. And there is a data set called top 1000 movies data set. I'm going to just import that. Here it is imported. If I look at the column, these are the columns which are there, but I'm interested only on genre, overview, and series title. So I'm going to take only that and create the data that is required for me. So only these three details that I'm taking. Okay, and in case any null values are there, I'm dropping the values there. And then before here, if you look at here, when I'm importing this data, I'm taking this data.overview. Data.overview is nothing but this description data to a variable called x. And this x variable, I'm going to take it for test data. Now this x contains all this overview column available there. Okay. So now this overview column details, I wanted to use this sentence transformer using this algorithm to transform the sentences available here to a numeric form. Okay, so it automatically takes care of transforming the detail. I am defining a model for the sentence transformer, and using this, I'm encoding the text data, and I'm showing the progress here. And the outcome of this particular execution is the embeddings. The embedding is nothing but you had the textual information. Computer cannot understand the textual information. We need to convert this text to a numerical form. That is what is called as embedding in the natural language processing. That is what is happening now. So now once the embedding is created, all the sentences are transformed into basically numerical form, but it will have all the words which are there. For example, your to, or, for, all these unnecessary words will also be there, part of the transformer as such, the embedding outcome. Okay, beautiful. So it has completed the embedding part. Okay, so this embedding data, I'm just moving it to an embedding data. Let me see the embedding data. So now if I see that, you see here all these are numerical values which are being provided there. Okay, and this you can take one specific embedding data and verify what is the outcome of it. So this shows for one movie, from the description, this is what the outcome. There are so many words, it has converted the words into a numerical form. Okay, but we don't know which is the important word on it, right? For that comes the PCA, the principal component analysis. So we are not going to bother about so many words which are there. I am bothered about the top 5 words. So I'm going to take from this embedded data, I'm going to create an array, and I'm going to create that array with the variable X. And I'm interested only on the top 5 word. So the number of components that I'm telling for the PCA is 5. Once I create the PCA object, I will fit that object for this X, the array that I have created. And once I created that PCA value, the top 5 values, I'm going to take it to a variable called PCA data. Once I receive that, for each and every movie, I will have the top 5 words which are important. So that is what you are seeing here. So the PCA outcome is basically I have processed all this data and taken the top 5 important data that I will be using for my processing. Okay. So now for each and every movie, you have the top 5 values there. Okay. So you can just look at the plot of the data that you have received, how the different words are grouped together in this pair plot. So this is how the data is actually represented in the pair plot. Okay, so now the important part. So now for all these 5 different important word, I wanted to identify the similar movies which are there. For example, the zero, it could be a movie. This particular movie has 5 different important words. The words could be like in the avatar we have seen. It could be your some some loyalty could be an important word, and like that there are 5 different words are there. So now all the movies data, that is the descriptions, are converted to this 5 important word. Now we need to identify similar movies. How do I identify similar movies which are all similar, near to this particular movie, the word which are there? Then those things are all considered similar one. For example, if there is another movie that has the similar kind of words are available there, it could be that this movie has an action, this movie has the details about loyalty, this movie has details about so many other details. And if there is another movie that is also having a similar kind of words, top words, then there is a match. How do I find these things which are all similar one for this particular word? That is where this cosine similarity comes in. Now you provide that X to this cosine similarity, that will give you the cosine similarity data for you. Now you have already identified the cosine similarity data. Now it is time to actually print whatever that is required. Okay, so now how do we print it? I'm just defining a method here in Python. So this method is going to take 3 parameters. So these 3 parameters are going to be processed by this method. Okay, you're just going to pass an index. It could be any index. and based on that index, it will print the actual recommended movies for you. For an index say 10, if the movie at the index is Avatar, it will print the top 5 related movie of Avatar. That is what it is going to print. Okay. So now to print the recommendation, I'm putting another variable called another parameter called print recommendation equal to false. If you are passing the second parameter to true, then it will print the recommendation. And if you want plot, this is still under development, but now plot is not coming. But basically, if you want a plot, then you can make this as a plot. Print genre, if you want to print, that can also be done. If you put true, then that will come. Effectively, what we are doing is based on the index, that index data from this cosine similarity, you are locating that index and sorting the outcome value, and you're taking the top 5. 1 to 6 is nothing but the top 5 item, and that is what the recommended one. And from the index as such, you are going to drop, you are going to take that the title of that particular item, and what is the movie and the index, and what are all the recommended option for the particular movie that you are going to display. The rest of them are just the details, you can ignore them. So this is the important, the 4 lines that you are seeing, that is the important one for printing the recommended movie. Okay. So now this is for plotting the actual outcome. That method we can define. Let me just run this code so that the cosine similarity is done. I have completed the run. Now, if I want to see randomly take some 4 different movies and display what are all the recommended movies and how the different movies words are plotted, I can represent them using this plot. Here it is going to generate this recommendation. For example, for a movie called Good Will Hunting, it is giving 5 different movies which are recommended. If you look at in this whole matrix of detail, these 5 movies are the top movies which are up approximately 0.8% of values there. Others are like, very small percentage point, it varies from point 0.2 to point 0.6, and these are the point 0.8, near to the point 0.8. So these top items were considered for your display. Similarly, if you take a Little Princess, it's all randomly generated. If I run this again, you will get a different movie. A Little Princess, these are the recommended movies because the words available in this were somewhat equivalent to the actual Little Princess. And similarly, you have this Wizard of Oz. You have, these are some of the movies that are recommended that you can actually present. So that you get the idea how this is working. So let us look at executing the code. So give recommendation, I'm just simply passing, you can pass any index. So based on the index, it will take the value. I'm passing true, recommendation detail also has to provide. If I run that, so that on the second index, the movie which is available is Dark Knight, and the recommended movies, there are 5 movies it is going to take: Dirty Harry, Batman Begins, Guardian of Galaxy, and Joker. I hope you will agree that, whatever the movie that is it has recommended, it has some meaning, because Dark Knight is Batman Begins, both are kind of related, and the movie of Dark Knight and the Guardian of Galaxy, approximately similar kind of a movie. And I can change index, and you get a different movie and the detail. I just change it to 3, and it is Godfather Part 2 is the movie, and what are all the different related movie. The Godfather, it is giving a wonderful option, and it is the first part. And Bronx Tale, American Psycho, Kung Fu, American Gangster. I would agree all the movies that is recommended were perfect, and that is how you get the recommendation. You can even put no need to provide recommendation, but give me the plot details, and that plot basically talks about what is the full plot in the sense, effectively what is the context of this particular movie. For the two as such, it is two is nothing but we have seen that it is Batman Dark Knight. And what is the what Dark Knight was a movie, and the Dark Knight's story, this is the probably the first one is Joker's recommendation is based on this, and Dirty Harry could be this. um, so Batman Begin, probably this is Batman Begin, and that is Gotham City is coming. So that details that you can see, and that is how this is the plot. Based on this plot, it has taken the top five words and it provides the detail. Likewise, you can make true for both of them and give a random movie, and it will give you all the details. What is it is recommending? What is the plot? And the details are being provided there. You can provide all true, where some random number, it will give you what is a movie that you wanted to see. Okay, so it's Thare Zamir Par. So it is taking some recommended movies there. So the last step what you can do is, for each and every movie, that you can actually combine that value with the first, second, third, and fourth recommendations, so that you can create this data and store it in a database. You don't need to even do it upfront. Whenever a person already seen a movie Silence of Lamb, you can directly look at providing the movies which are related to them, right? Vikram Veda, Seven, Dirty Harry, and so on and so forth. Directly provide that movie for him. So this is how a content based recommendation actually works. Any questions, team? I hope it is clear. Okay. So let me go to collaborative filtering. Okay. We looked at collaborative filtering, where the example that we looked at is in terms of, okay, I have a set of movies, and there are some people who have already rated for this movie. Like Mali has already rated Avatar 5, and Gokul also rated Avatar 5. Now if I need to provide, for when a Gokul logs in, what movie to provide, because both of them has rated 5, I can take the details and identify a group the people based on their interest. And now here in this case, I can group Malli and Gokul together, because they both have rated this Avatar 5. So their interests are somewhat similar. So because Malli has given 4.0 for expandable, I can look at providing Gokul for the same outcome, expandable as the next time. So for telling people, right, collaborative filtering. Okay, how do I implement it in the code? So that is where it is getting a little interesting. Okay, where to do that, if I am able to group the people who are there in the whole database to a certain group, and keep them to a certain group, whenever a new user comes in, or new user with a existing interest comes in, I can look at putting this particular user to a specific group, and based on which I can provide a recommendation. So that is one approach. That is what collaborative filtering. So how do I do it? So now here, this is what the matrix representation of what you have seen there. Now what we wanted to do is, if I can identify what could be the Gokul's rating for these movies, based on which I can recommend him which movie to show, right? If I see here, because I have only three users, and Gokul and Malli has a similarity, so I can look at recommending, identifying Gokul, say he might also give above 4.0 for this movie, and I can start recommending this. Here the other problem is, I don't have any equivalent person here who has done that, so I will not be able to tell whether I can recommend recommend Spider-Man to him or not. So we need to see how we can actually solve both of the problem. Okay, so now we're going to look at how collaborative filtering helps in solving it. So to do that collaborative filtering, the first thing that we need to understand is a basic k nearest neighbor algorithm. So we're going to use the k nearest neighbor algorithm based collaborative filtering is what we're going to use. This k nearest neighbor algorithm is very simple if you understand. The k represents the number of groups that we're going to create for a specific feature. Let's take users as a feature. So if you take users based on their history of movies that they have watched and the type of movies that they watched, we can actually classify them to a certain number of k. If the k is 2, then all the user will be grouped into two groups. If k is 10, all the user will be grouped into 10 groups. So this diagram explains how the grouping actually done. Here there is only two class that is being taken, class A and class B. So from the previous example that you saw, there is a set of people who are all in class A, sorry, class B. There are a set of people who are in class A. Okay. So now in this case, assuming a new user comes in, and when that new user comes in, this is where does this particular user falls under, whether it is a class A user or class B user. That's where a distance will be calculated from the new user's position to all the nearby users who are there and whose position details are very less, in terms whom this particular guy is very nearby to, then based on which he will be allocated to either this group or this group. And once he is allocated, based on that particular group's interest, the recommendation will be provided. Okay, so assuming this particular person belongs to this particular group and the distance is less to all the different points which are there, because of that he can be recommended with some of the other movies watched by the group of people in this particular group. That is what the basic behind the collaborative filtering. This is k nearest neighbor algorithm, and this is how it works. Now we're going to use the same KNN for first group the users, and once we group them, and based on the actual new user data that we're going to give, it is going to give us how we are going to provide the outcome. Okay, let me just walk you through the demo so that you will understand it much better. Okay, right, go back. So now KNN based item. Good. Okay, so now let me just the first step is, so the data specific to that this particular notebook, there are two data sets are available, movies and rating, and I have already uploaded because it is disconnected, it is not there. I have already shared the details. I'm going to upload this data to the notebook. Movies and ratings, CSV file, I'm just uploading here before I actually start the process. So it takes some time to actually upload the data. I'm using Google Colab for all my recommendation, all my demos. All these notebooks are already shared in the GitHub. So you can also directly put these into the notebook and start enjoying your, you don't need any environment to be set up, nothing. Start Google Colab, upload your code and start executing. All will work beautifully. Okay, so I've just uploaded the data. So now the next thing is I can start executing the code. Let me just go here. So first is panda numpy is for your data processing, and I'm reading the movies and ratings, and there are multiple rows, columns. I'm interested on only specific columns, so those columns I've explicitly provided. So in the movies, I have two columns. One is your movie ID and title. Another is ratings. You have three columns. Movie, both of them have movie ID as the common item. So you have user ID, what is his rating, and what is the title of that particular movie. Okay, different users might have given different rating, so that informations are captured here. Okay, so now I'm going to combine this two data table, combined movie with a rating, and I'm going to get. Okay, so now, okay, sorry. So first I need to merge this outcome. Once that merging is done, I skipped that one. So I need to execute df. So df is done. So now what this gives is I'm merging the details for this particular movie. How many ratings are there? Okay, so that is the information, the total rating count. For there are so many movies, the number of ratings that you received were very, very less. Okay, so that is very, very big problem for me, because when I wanted to identify based on the ratings, if the number of ratings are very less, I have to actually do some cleanup work. So let me just take the full data, including the user, movie, rating, and the number of total number of ratings. Okay, this will help me to filter only the top items there. Okay, so now if I look at the total number of ratings, what is the distribution of the values that I can see? There are around 8,700 records are there, but I don't want to take which take movies which has only very limited number of rating. That will skew my whole outcome. So I want to specify a minimum of 50 rating should be there for a movie. Only that I will take for my actual implementation. So I will just say 50 rating. I'm going to filter that whole existing total rating movie filtered by 50. Only total rating greater than 50 will be there, and only that I'm taking that as a outcome. I'm storing it in this data frame. When I execute, now I have a filtered data set, and if I see the shape, it has around 41,000 record with five different columns. And this has, I'm sure that this has the total rating count more than 50. 41,000 records are there now. Okay, so now from here, let me create a pivot table. The pivot table, the approach is going to be all the user detail will be the rows, and for each and every movie, what is the user has given rating. If the user has not watched that movie, the rating will be considered as 0. Okay, for example, here a user 7 has provided a rating of 4 for this Space Odyssey. He has not seen any of the other movies. I'll tell you why we are doing this here. This will give a clear picture of a sparse matrix, and this matrix is going to help us identify our nearest neighbor. So this is going to, so okay, this we have created now. Movie features data frame is going to have this particular pivot table part of it. Okay, so now we're going to create the sparse matrix. I'm going to take this particular data frame and putting into this sparse matrix as a matrix form. I'm creating this, and all along with that I'm defining the nearest neighbor algorithm through sklearn. And this, I'm creating this model nearest neighbor using cosine, and on this model I'm fitting for the data that I have. This is the data that I'm fitting. Let me just run it. So once I fit it, that fit data is fit. Now when I see the shape of it, there are over 450 rows and 606 columns are available. That means 450 movies and 606 columns users are there as such. Now you can just check what is the nearest neighbor for a random index. Okay, here what I'm doing is, out of this shape of 0 is nothing but 450 movies, I can choose a random choice. So in this random choice, the query index is, it is going to take, previously it took 251, you can take anything. So this 251, when you give this to neighbors detail, the the model dot neighbors, it is going to give you who are all the neighboring users for this particular movie as such. Okay, so if I run it now, here now it is taken 351. So if I look at here, this is the head of it. Now I can just, the distance and the indices are going to give me all the indices which are near to this particular movie 351. Okay, I can look at printing that 351. What is that movie? The 351 movie is called Shining. The Shining is the movie, and these are the top 5 recommendation based on the actual nearest neighbor detail that is being provided. If I execute this again, for example, the random choice, I run it here again, it is going to give 77 for this movie. I can just run here for the 77 movie. It is a completely different movie, and in this, for this movie, these are the 5 recommended item based on the nearest neighbor option that we have put forth there, right? So this one uses the nearest neighbor algorithm for identifying the nearest movies that has to be recommended for any specific movie. So how does it identifies the nearest movie? Because based on the user rating that is being provided, and that all the movies will have their own ratings, and that rating information make sure that provides the nearest neighbor information based on which these movies are being recommended, right? Hope this is clear at a high level how you can actually provide the nearest neighbor based solutions there. Okay, so let's move on to the next any questions, you can stop me and ask team. Okay, okay,
Prasanna,
so
just
maybe,
one question here. Uh,
yeah.
can we evaluate our model and results? Is there any way so that we could?
Effectively, yeah. So now here it is a when you have a supervised algorithm, there you will have an approach of evaluating. You have your precision, recall, and your details, like accuracy and all will be there. When it is a non-supervised algorithm, the actual thing is basically it is giving you, it is a non-supervised algorithm. KNN is basically a non-supervised algorithm. It takes, based on the data that you are going to provide, it is going to have a classification of the details there, and from the classification you're going to get this detail. So one evaluation that you can do is probably the tweaking of number of different classes that you are getting. So based on which you can actually look at, now I want only 5. Now you can look at increasing the number and decreasing the number and see how it is actually performing. So that is one way of doing things here. Okay, that is the only approach.
Okay, got it. Thank you.
Hope I helped you. Yeah. So the next approach is a very interesting approach called matrix factorization. So before we get into there, so let me just give a basics of what is a matrix factorization. Okay. So I'm sure we all have read some basic matrix from the mathematics. Let's say we have a matrix like this. I have 2 rows and 3 columns. Okay. And the first row has 1, 2, 3. Second row has 5, 10, 15. Okay. Matrix has something called cross dot product and the cross product. So now here the matrix that I have can be represented two matrix. This is two matrix that I have here. So the first matrix I can say 1 and 5, and the second matrix have 1, 2, 3. If I do a cross product of these two particular matrix, I can get back whatever the original matrix that I was looking at. Okay, I was looking at. Now here, how does this work? So you basically multiply the details of the items and provide that here. For example, 1 into 1 is 1, and 1 into 2 is 2, 1 into 3 is 3. Now 5 into 1 is 5, 5 into 2 is 10, and 5 into 3 is 15. So this is how you basically bring in. So if you have a matrix like this, a bigger matrix like this consists of 6 data point. Now the 6 data point matrix can be reduced or stored in a way that it has only 2 items and this has 3 items. So total of 5 items can represent a 6 item matrix. For a small number of items, we are looking at, this is going to have 5 item and this is going to have 6 item. There's no big deal, right? But assuming that you have a millions of record, and the millions of record, as you grow, instead of storing this information in a single matrix, and if you factorize them like this, and using the factorization, you'll be able to achieve whatever the storage that you wanted to, whatever the information that you wanted to store. Okay, so that is the basic premise of matrix factorization. I hope this is clear, and it is the base premise with which we are going to apply how the matrix factorization is going to help us on defining our recommender system. Okay, so now we have seen our matrix here, assuming that Gokul also seen a lot of these movies, and all the people have seen the movies, and they have provided different rating for them. Okay, and the movies which are there, there could be multiple uh, genre. So I'm just taking action and fantasy as a two genre for the whole solution. Okay, so now here, if you look at this particular matrix 4 6, there are basically um, 4 8 12 data points are being stored as part of the database. Okay, if if there is a way that I can actually factorize this particular matrix using some other feature, so that I can understand more about the data, I can have a less amount of space for my storage as such. So that is what the goal of this particular matrix factorization. So the same movie, same user, but I have a genre information like action and fantasy. What I can look at doing is, I can look at including the genre detail, and based on the genre detail, I can classify the details that Mali likes action movie, but he does not like fantasy. Shan likes a fantasy movie, does not like probably action. Gokul is also like Mali. We already know he likes action movie, does not like a fantasy movie. So, like from a user perspective, I am classifying this uh, with a different genre, and similarly from the movie perspective, I am also modifying the values into different values. Okay, so now if I apply the matrix factorization rule, if I combine these two matrix, if I do a cross product of these two matrix, now I will get this particular matrix, right? That is a basic premise. Now here what we are bringing in, what we are adding is basically we are adding a specific genre as a feature. Based on the genre, we are actually building the recommender system. Okay, we are actually classifying the detail. Okay, so now you could ask, okay, fine, how do I bring in these metrics, assuming that I already have the data like this. I already have Mali has given these ratings for these movies, and all these data is already captured for each and every movie. And how do I build this factorized matrix? What is the approach to build it? That is a basic question. Because how do I split the data into two different way, so that it, when I'm combining it, it is going to provide me this particular matrix. The matrix that I want is going to be exactly matching with the data that is being already provided by for the movie by the user. If I'm able to do that, that is fantastic. Okay, that is a big question. Now how do I do it? So that is where machine learning comes into picture. So now how do I build these two metrics? That is our main problem statement for this. Okay, if I build it, then using this factorized matrix, if a Mali is there, I can identify all the recommended genres for Mali and directly provide the corresponding outcome. Similarly, if I know what genre Mali is looking for, I can look for the corresponding movies which are having a similar genre, which are rated high, and similar movies can be directly taken and provided there. That's the idea behind it, how it is going to work. Let me just look at the mail. Okay, 1 second, please. Okay. Is it okay now? You're able to see the video, Mr. Shambaji?
Yes.
Yes.
Okay, great. Okay. So, so effectively, that is what we need to achieve as part of our goal. So, how do we do it? So, we need to build these two metrics based on the previously identified metrics there. So, that is where our machine learning comes into picture. Okay. So, the approach is we initiate these two matrix that are there. You initiate it with a random value. These two matrix has to be initiated with random value, and you populate this value. Once we populate, we do an error prediction from when I multiply these two value. What is the value coming? Is it expected value or less or more? Based on which the error value will be calculated, and apply something called a gradient descent, that is part of your machine learning process, and iterate on repeat this whole process to reduce the amount of error that you are getting as such. Okay, so probably the first time you kept a zero here and you got a different outcome, so you are correcting this probably because it requires you to increase the value zero point 0.1. Next time you may have to increase to zero point 0.2, zero point 0.3, and so on and so forth. That way you have to iterate on modifying the value based on the error that you are getting. And once you achieve to a level that your errors are very minimal, that represents the actual uh, factorized matrix that you got. Using that matrix you can use for your actual prediction operations, recommendation operations. Okay, now we will see in demo. So now the complexity of the whole process has been already taken care by some of the libraries which are there. So let me just show you matrix factorization, and this also utilizes a data set. I'm going to use the data set first. The data set name is u.data. That is not available here. Let me just upload the data, u.data. So, okay. So there is a library called matrix factorization library, and this library basically helps you on performing this. I'm going to first install that. So now it is installing that matrix factorization library. Once that is done, and I can get the three important feature: kernel matrix factorization, baseline model, and train update test split. These are the three important things I'm importing from that matrix uh, matrix factorization. And panda and metrics, mean square error, I'm taking it here. And I have uploaded the data. The data is called u.data, which is also available here. Group lens, it's a movie lens data set, and that data set I'm taking the details and I'm importing the data. Once I imported, let me just see the movie data rating details. And here actually we are taking the x and y split. The the ratings are going to be at the y, and the user id and the item id are going to be at the x. And once I have the xy, I need to split that into train test split. That I'm doing it using this train update test split. And once I do that using kernel matrix factorization, which algorithm, that whatever the complexity I told you, it automatically takes care of matrix factorization. And it actually takes care of I'm creating the model for it and fitting that model with the training, x train and one train, y train. When I run this, it is going to fit because I've given a epoch of around 20. So it is going to run for 20 time. So 20 time has done. And once I'm done, I'm updating the users details. And once that is done, I can use that matrix factorized matrix for my prediction as such. So now for this prediction, let me just see root mean square error. That has to be it is 0.98. And now I can give any user. For that user, it will look for the matrix, and it will provide for this user what is the items which is recommended as such. So I'm hypothetically taking 200 as a user. When I run it, it gives the details that these are some of the top rated prediction for this particular user. Okay, so this is how you will use. So all the complexity of you creating the algorithm is masked by the matrix factorization algorithm. You provide any user. I'm going to say 210 I will take. I don't know whether that user is there. Yes, it is there. And for this 210 you are getting the corresponding rating details, which movie that is better. If a different movie is coming with the details, then you can use that for your prediction as such. Okay, so that represents the matrix factorization approach. There is a library called matrix factorization library. You can install and you can use that for your machine learning predictions, recommendations details as such. Okay, so that covers the three approaches which are prominently used right now in the field. Now the latest developments, if you look at where on the matrix factorization, if you are having large amount of data and the machine learning process is pretty slow, the gradient descent process is pretty slow, that's where you have some deep learning based approaches of matrix factorizations, where the recent developments there. But apart from that, if you look at predominantly all there, like Amazon or your Netflix, or majority of the recommendation systems predominantly utilizes these approaches for providing the recommendation to the users. Okay, so some of the constraint from recommendation systems, the data size and the dimensionality, because there could be some users who may be a new user who has not given any outcome to the any input to the system. In that case, it is very difficult for you to predict what could be the recommended one. So that you will predominantly do a iterative process. Once you gather more data, you will start processing it and you will start providing the data, providing better recommendation. All machine learning problems are iterative process actual. And extreme sparsity in terms, sparse matrix were having a lot of zeros on their structure. So the extreme sparsity actually reduces the performance of the recommender system. And it is difficult for model serving perspective, because each and every user specific detail has to be provided. So each and every user who is accessing something, you need to provide a recommendation. So think of the amount of serving infrastructure that you need to have. And there could be wide variety of data that can actually influence the whatever that we have shown is all toy data sets like movies, 2 3 columns, and so on and so forth. These are for your understanding, but when we go to a real implementation, it is going to be a much more complex one. And when you look at the complex data structures like videos recommendation and audio recommendation, the complexity goes manifold. So these are some of the constraints. There are many other algorithms available for audio and video as well. So they take into consideration of what is the context of the video, even to look at inside the video and provide you the recommendations as such. So okay, so those are some of them. So these are some of the references you can refer. And that comes to an end of today's session. So any questions, I'm happy to answer.
Hi Prasanna, Purnima here.
Yes, Purnima.
Prasanna, my first question is the recommendation system we use, this PCA, right? So it takes the top five components. So you showed in the numeric format, right? Does it convert them into keyword? The keyword is being translated to the number format, right?
First step
Is it
is
the
converting keywords to numeric format. That is the first step. So that is
okay?
what is achieved by using your sentence converter encoder. Actually, the sentence encoder basically takes your sentence and converts that to a numerical encoding format. And once
Mm-hmm,
the numerical encoding format is received, and you apply the PCA for your dimensionality reduction. The PCA basically does the dimensionality reduction in the sense it identifies which is the most important features. It is a feature reduction problem. So
mm-hmm,
you once you have say hundreds and hundreds of dimension, but you may not be needing all this. So you need to reduce that. That's where PCA comes in, to reduce the number of dimension to whatever the dimension you want. Here in this case, I've taken 5 as an example.
mm-hmm.
So that represents, in your problem here, instead of features, it is basically the number of keywords. That is how we are taking. So the number of keywords, the top 5 keywords we are taking for our predictions.
Okay, and it compares with the whole content, or the content
So
it's also was split into keywords and then compared
correct.
for
So
the
now for
similarity.
all the content will get converted into first keywords. That is done by
Okay.
using your sentence details. That is the
Mm-hmm.
first step. And the second step is, now the sentence could be having 100 200 words. I don't want all of them. I need to reduce that to top 5. So all the movies content will be reduced to say top 5 keywords there. Okay, so that is
Okay.
the second step that is achieved using PCA. Okay. The third
Mm-hmm.
step is basically you need to do a cosine similarity prediction. Okay. You have to apply
Okay.
cosine similarity. The cosine similarity, how it works, the basic works like this. So you have say X and Y coordinate. Okay. So let's
Mm-hmm.
say there are two words which are there. The two words, the one word is here. Let's say a second word is here and the third word is here. Okay. In our case, let's say it will try to predict an angle between these two words. So now assuming that this is word A, this is word B, and this is word C. Now when you compare A and B and the angle is very less, that means they are kind of more dependent. Now you take A and C, the angle is basically very high, that means they are not dependent. So this is
Mhm.
similar, basically that is what is achieved by using cosine similarity. So this angle is less, so we can consider that A and B are somewhat similar and A and C are not similar at all. Okay, so that is the
Okay.
concept. So that is being applied with all the full data sets for all the values and keywords that you have got. For example, for avatar you have got probably five different words. Using that five different word, you need to scan through the whole database and find which are all the words on which movie which has a similarity to me, that is achieved by using cosine similarity. Okay, so
Okay.
those movies will, specific to avatar, those movies will have, which are all having the highest relate, that is similarities, will be noted down there. Okay, so that will help you filter. You can, it will have all the, you have 500 movies, all the 500 movies will have a similarity score, but out of this 500 movies you will take only the top 5 because you are interested on only the top 5. So you take the top 5 movies which you wanted to see because that is similar to avatar, that is what you are looking at.
Okay. Got it.
Okay,
Yeah.
okay,
And one more
wonderful.
thing I just wanted to discuss. I had a question. Like, I mean,
Yeah,
not completely related. So I have some taxonomy field and a
okay,
risk rating for that, a rating given to that, and average score
okay.
and number of people who have given that score. So based on all these features, can I? Is there any method to come up with a rating? We don't have any prior rating though. So using these features, like if we want to come up with any number called as rating or something, what would be the ideal way to do
you
that?
al- you already have a rating, that's what you are saying, right?
Um, that's something given by people, like 1 to
Mm.
5, but we
Okay,
don't want to consider that rating alone. I want to combine the other features also, like the score given and number of people have given that score. Based on that, can we come up with a rating? Because I'm just
absolutely.
trying to solve the bias problem where it can, because since people are rating it, there could be a risk of being biased. That's why.
Correct. I'm trying to understand it. So, okay.
Hmm.
So the people are rating it, but you don't want it, you want to build a new rating system,
Yeah,
but
something like a
that
top
is
top I can find.
understand. Okay. So for that, you wanted to consider not just the user's rating, but also a couple of other parameters, right? That is
Correct.
what you
Yeah.
wanted to do.
Yes.
Yeah, yeah, absolutely. Yes, it is possible. Even the example that I have shown you, you can take probably, is it for a product? Is it for a specific item? Based on
Yeah.
that specific item, you can provide the related item. See, our goal on the recommendation is not for automating that particular product, but for identifying some of the related one, right? So that is where
Mm.
the recommendation system comes in. Okay, so your problem is basically for that product itself, you wanted to come out with a new rating system, right?
Correct.
Yes, you can actually take some of the concepts here and you can actually apply there as well. Absolutely possible. Yes.
Hmm. So, what would be the
Okay,
ideal
but I'm
method
not.
to,
Okay.
solve this bias problem? Is what I was thinking.
So I Yeah, so basically what bias problem as such, I am trying to understand on what context that you are trying to solve so that I can recommend the details. See, is it your bias on your machine learning algorithm that you are trying to solve, or is it the user's bias that you are
Users
trying to solve?
bias.
Okay, so now user's bias. So now you have a user who has already rated a specific product,
Mhm.
right? Now,
Right.
what are all the bias that you think that has to be solved here?
The rating that he gives, and we have a score, the average score, and number of people who have rated that. So something on that lines.
But that is not bias, right? So, I'm trying to understand.
Okay.
The user has given a rating. So,
Mhm.
define bias from a user point of view. Can
So,
you
for
define
example, that guy might have for the taxonomy, there might be few taxonomies, and somebody would have rated five, and for the same classification, somebody would have rated two and one.
okay.
How would we come up with saying like, okay, this is the top rated product?
Okay, so simple one is yeah, you have to take an average of it
Mhm.
and basically bring whoever is based on number of users who have provided the outcome, and out of which whoever has provided whichever product has got or received the highest rating would be the top product, right? Now here,
Okay.
where is the bias? I'm trying to understand where is the bias here. See, the bias comes when
Mm.
something else is influencing the outcome of it. That is what bias is, right?
Mhm.
um, Now here I'm trying to understand what is the
So
bias
somewhere
that
it
you're.
is like for each of the product, I have few products where people have rated all from 1 to 5. Everything is there. So.
Correct. Yeah, you have to take a grouping of number of people who have rated 5, and the number of people who have rated 4, number of people rated 3, number of rated people rated 2, number of people rated 1. So
Mhm.
if you have the number of people who have rated 5 is more than the number of people who have rated to 1, that could be considered as, I mean, rating as 1, that could be considered as that product is highly rated, because when the people will rate to number 1 is when they see lot of problem on that particular product. Okay, so I'll give you an
Mhm.
example. So you have a product where 100 users have rated a product. For the hypothetical scenario, we'll take so 25 people have rated 5 star and 75 people rated as 1 star, just for an example. Okay, so now there is a second product where 50 people have rated 5 star and 50 people have rated 1 star. Okay, so now which is the best product among these two? The number of users are constant. Here both were rated 100 by 100 people have rated both the product, right? And the second one
Mhm.
is the number of people who have rated 5 is more in the product 2 than compared to product 1. So you take these two, then the product 2 wins when compared to product 1. Okay, so here the approach that you have to do is you have to give a weightage to multiple different feature. Weightage in terms of if the number of people who have rated for a specific product 5 rating to a product is more, then you give more weightage to that particular user, particular product, then number of people who have rated 1 for that particular. Am I making sense?
Mhm.
Am I confusing?
Yes, yes, yes. No, no,
Okay,
got it.
you got it right. So you have to give a
Yes, yes,
weightage,
got it.
and based on the weightage you have to basically classify the whole thing, and the weightage
Okay.
should vary based on what you wanted to achieve. So here I wanted to differentiate. There could be a product, okay, let's say it has been rated only by 25 people, but out of this
Mhm.
25 people, 24 people have rated that product 5 star. Only one guy has given 1 star rating. Okay.
Hmm. Hmm.
So now if you go with the weighted approach, among the three products that we just looked at, the third product will take the highest weightage, because out of the number of people, the
Mhm.
rating that was given by 24 people, which is almost 98% of the people, have given the five-star rating. So the product three takes the precedence over all the other two products. So that is the top product from your case.
Okay.
And here you may have to have a kind of a baseline. Minimum these many ratings should be there to be part of your final outcome. That should be there. Minimum, say 100 rating, 200 rating, something like that. Then only you will consider for your calculation at all. So that kind of a
Okay.
basic entry criteria should be there, and then you have to apply this logic there. Hope it makes sense.
Yeah, got it. Thanks, Prasanna.
Yeah, sure. Any other question, team? Wonderful. If there is no questions, and thank you very much for patiently listening, and all the very best. And we'll meet in the next sessions. Okay. Thank you.